Today we're going to move on with inverse trig, and I want to pick up where we left off yesterday, which was looking at sine of x, and we said that it would have an inverse if I restricted the domain to negative pi halves to positive pi halves. And we said that it would then only look like this, go from here to there. And I know my graphs may be off a little there. Let me fix that because it's not very pretty. So there's our graph of sine after we've cut it off at negative pi halves and positive pi halves. But we still haven't looked at the inverse sine function. Now let's think of what's going to happen here. We are going to reflect this across the line y equals x. All right? Now, if you recall, when we solve to find an inverse function, we switch the x and y coordinates. Okay? So let's think of this for a minute. Right now, the coordinates of this point are pi halves 1. What is it going to become after we flip it? It's going to become 1 pi halves. All right? So after we flip this thing, and we're not going to do it on this page because it'll get kind of messy, it will become 1 pi halves. The coordinates of this point right now are negative pi halves negative 1. After we flip it, it will become negative 1 negative pi halves. Okay? So our new graph for the inverse sine function after we reflect it is going to have different coordinates. Okay, so when we look at the graph of inverse sine, the coordinates are going to go from 1 to negative 1. Okay, let's go back here. Instead of going from negative pi halves to positive pi halves, it's going to go from negative 1 to positive 1. And then down here it's going to be negative pi halves to positive pi halves. Okay? And so if we look at our original graph, we're just going to kind of flip it, and it's going to start down here. All right? And you just kind of have to picture the curve being flipped. I will go ahead and draw on this one so you can see it. The curve kind of being flipped like that. All right? So your new graph is going to be kind of like that. Okay? That's kind of the graph of inverse sine of x. And it's very short, it's cut off, okay, and that's okay, because that's the only way we can have an inverse. Now let's look at the inverse graph of cosine. Now I'm not going to go through everything I just went through with cosine. I'll just remind you that yesterday for cosine we cut it off from 0 to pi. All right? Yesterday we cut it off from 0 to pi. So after I flip it, remember all of our coordinates are flipped and it's reflected across the line y equals x. The graph of cosine is now going to look like this. This point right here will be 1, 0. And it's going to kind of do a deal like this, and then the coordinates of this point will be negative 1 pi. Now, that one's a little bit harder to see, but it does work if you think about the fact that in my original, this point was 0, 1, and now it's 1, 0. Okay? Because it got reflected. And this original point was pi negative 1, and now it's negative 1 pi. All right, so it does make sense if we remember that for an inverse we switch the x and y. Now, what is more important, though, at this point is understanding something for evaluating. Okay? Let's come back to our sine function where we cut it off. We cut it off, everybody watch, we cut it off from, I'm going to use a new color, we cut it off from negative pi halves to positive pi halves. We restricted the domain. Now let's think of that in terms of our quadrants. Here's 0. Here is pi halves. Okay? Remember this over here is pi. Remember labeling all of these quadrants? Now this one down here, okay, this one at the bottom, we could say that's 3 pi halves, couldn't we? But couldn't we also say that it is negative pi halves radians? You remember how we swing a negative angle down this way, right? All right. So what am I getting at? This is a very important point when talking about inverse sine. We said we restricted the domain from negative pi halves to positive pi halves. In other words, we're only looking at these two quadrants right here. Quadrant 1 and quadrant 4. So when we work with the inverse sine function, when we work with y equals the inverse sine of x, because of our domain restriction, it is only defined in the first and fourth quadrants. Very important. You'll see how that works in just a second. The inverse sine function is only defined in the first and fourth quadrants because of our domain restriction. All right? That is for inverse sine. Now, inverse cosine, didn't we restrict inverse cosine to 0 to pi? So let's think of that on the quadrant plane. If I look at inverse cosine, it's restricted from 0 to pi. So if it's restricted from 0 to pi, that means it is only defined in these two quadrants. The first quadrant, quadrant 1, and the second quadrant, quadrant 2. So let's make a note here. Inverse cosine is only defined in the first and second quadrants. Okay? And for the one I'm not going to spend a bunch of time on right now is inverse tangent. Because all I'm going to say is that inverse tangent is just like inverse tangent is just like inverse sine. It's only defined in the first and fourth quadrants. Okay? Only defined in the first and fourth quadrants, just like inverse sine is. All right? So, let's get to some examples like you're going to see in homework tonight. We're going to do one skill and one skill only tonight. Let's get rolling. you're going to be asked to evaluate. And guess what we're going to use over and over again? We're going to use the bow ties. We're going to use the triangles that we spent so much time on and are so important. Let's say that I am asked to evaluate the inverse sine of 1/2. Well, the first thing that we need to understand is what the heck does that mean? All right? Well, here's what it means. We are actually wanting to find out the sine of what angle, we'll call it theta, equals 1/2. This one's a pretty easy example. Now, let's think through this. I'm going to go slow. This one's pretty easy, but I still want to go slow. The sine of what angle is 1/2? First off, where is inverse sine defined? In the first and fourth quadrants. All right? That's the first thing we need to remember, is that it's only defined in the first and fourth quadrants. The next thing we need to pay attention to is this value over here positive or negative? This is positive. Okay? Positive value. The next thing we need to do, sorry for that interruption. We've now considered what quadrants we're working with. We've now considered whether my value is positive or negative. The next thing we need to remember is the little rule that I told you. Do you remember all scholars take calculus? Okay. Remember what that tells me. It tells me where the functions are positive. Which functions are positive in which quadrants? So let's review that real quick. All of them are positive in quadrant 1. All of them. Only sine and its brother cosecant are positive in quadrant 2. Only tangent and its brother are positive in quadrant 3. And only cosine and its brother are positive in quadrant 4. So let me ask you a question. We're working with sine. I can only work in the first and fourth quadrants. So when we look at inverse sine, we have to remember once again we're only looking at the first and fourth quadrants. We're only working right here. So that's why I made a big deal out of, is this value positive or negative? As soon as we see this value is positive, then I know we have to be working in the first quadrant. I have to be right here because that's the only place where all of them are positive. Down here, sine is negative. Okay? In this quadrant, sine is negative. Okay? So as soon as I see that I'm doing the sine of what number equals positive 1/2, I know I'm in the first quadrant. From that point, it becomes very easy. Because as soon as I see 1/2, let me ask you a question. Am I thinking about a 30-60-90 triangle or a 45-45? I'm thinking of a 30-60-90, okay? And so I know that I'm going to do the sine of some angle, okay, the sine of some angle, and I'm going to get 1/2, right? Well, what is sine? Isn't it opposite over hypotenuse? So that means this has to be 1, this has to be 2, right? And then, of course, this is radical 3. So once I know that, now I just need to label my triangle. What does this angle, theta, have to be? Well, over here, the side opposite is 1, so doesn't it have to be 30? Right? Problem is done. Theta equals 30 degrees. And this is why I made a big deal about doing the triangles, all right, because now they're going to save us and make this a lot easier. All right? Let's do one now where sine is negative. What if I'm asked to do the inverse sine of negative radical 2 over 2. All right. Well, now we are saying the sine of what angle equals negative radical 2 over 2. Now, is my value positive or negative? This time it's negative, which means I have to be in the fourth quadrant. So I'm going to draw my triangle in the fourth quadrant because my value is negative. For inverse sine, it's always going to be drawn in either the first or the fourth quadrant because that's the only place it's defined. Now, here's the next thing. You should recognize this value. Does that come from a 30-60-90 or a 45-45? Comes from a 45, doesn't it? So this is easy. If you see that one for sine, I know that's 45, I know that's 45. So my angle theta is 45 degrees. Okay, but wait a minute. We don't just say 45 because which way did I swing down here? Didn't I swing in a negative direction? Right? So it's not just 45. Because it's in quadrant 4, theta is negative 45 degrees. All right? Now, let's do some with cosine now. Okay? How about the inverse cosine of negative 1/2? Well, what we are asking is the cosine of theta, the cosine of what angle equals negative 1/2. Now we have to remember, inverse cosine is only defined in which two quadrants? It's only defined in this one and this one. Now, all scholars take calculus. Out of those two, all scholars, out of those two, which of those two quadrants is cosine negative? It's in the second quadrant, okay? They're all positive in the first quadrant. In the second quadrant, this is the one where cosine is negative. All right, over here in the second quadrant. So I know that I have to draw my angle in the my triangle in the second quadrant. I know it's going to be over here. Has to be, because that's where cosine is negative. Okay? Now, this one's easy again because don't I recognize this 1/2? Right? Here's my angle theta. And theta is defined, or cosine is defined as adjacent over hypotenuse, right? So that means this has to be 1, this has to be 2, and this has to be radical 3. So now we need to label my triangle. This will, since this is the side opposite of the 1, that's 30, and theta has to be 60. Now, we're not quite done. The answer is not 60. This is where we have to use the reference angle because technically the angle is this one. So do you remember finding the reference angle in quadrant 2? We just do 180 minus 60. So the angle that we really want, theta, is 120 degrees. We just used the triangle to find out which one it is. All right? It's the cosine. And let's think through this. This does make sense because if I did the cosine of 60 degrees, I would get positive 1/2. Right? Well, this said the cosine of what angle is negative 1/2. That's why we have to use the reference angle and get 120, because 120 is where cosine is negative. All right? We're doing real well so far. Let's do one with tangent. let's say that I had the inverse tangent of negative radical 3. Well, first off, remember that I said tangent is just like sine. It's only defined in which two quadrants? The first and the fourth. Okay? Inverse tangent is only defined in those two quadrants. Now, out of those two, all scholars take calculus. Isn't it negative down in the fourth quadrant? So since this value up here is negative, I need to draw my triangle down in this quadrant. Okay? Now, tangent is opposite over adjacent. All right? So this, we're saying the tangent of theta equals negative radical 3. Well, that's the same thing as negative radical 3 over 1, isn't it? So that means that if this is my theta, the opposite side is radical 3, the adjacent side is 1, and this is my 2. And now I just need to label my angles. This has to be the 60-degree angle. The theta has to be 60 because it's opposite the longer side, the longer leg. This has to be 30 down there. But remember what we said, because it's down in quadrant 4 and we're swinging this way, my answer is negative 60. Theta is negative 60 degrees. Okay? And we are going to stop there for today.